Lisa, come on up here. So Lisa, we'll start with you if you have a rebuttal for Patrick. And any sort of galactic references you want to make?
Galactic and or universal, yeah. So Patrick's points are all well taken, and those structure activity cliffs and those kinds of concepts have been observed for a number of series of different types of compounds that we have these types of series data on. And so we do need to be cognizant of that possibility. We don't. I don't think we have to say, though, that we know nothing about our dodecaphenol, or that we can't make a decision about dodecaphenol, because, as I pointed out, when we don't make a decision, we make a decision. And so we still have to take our best shot at understanding these things. With respect to things like the possible differences in metabolism due to the differences in lipophilicity, I think we acknowledge we might have an additional uncertainty factor involved in the process to account for that. And again, I think it goes back to how important is the decision, and do we elect to do nothing, or do we elect to make our best assessment? And then if it's an important enough decision, then somebody can provide some additional data to help clarify the situation. So I don't, while all of these things are potential concern, I don't think any of them negate the possibility of using this in vitro bioactivity data to help us anchor a read across or extrapolation from our existing data sets.
So one real quick point of clarification. At this phase, they're still wearing their pro and con debate hats. In the panel discussion, they can take them off for open discussion, but they're still holding that. So with the hat still on, Patrick.
Yeah, so I have a very kind of Bayesian approach to science. Any additional information, in my mind, is a good thing. You can't. If as a modeler, adding another parameter can't make your model fit less. So I can't argue with you that it's not a bad thing to incorporate this. My argument is that it is so much uncertainty tied up in this, and we're not even. I left out basically all of the uncertainties that would be there in a traditional read across, the species extrapolations and things like that. That essentially there is no difference from saying that this is zero.
So if we have any comments from the audience, please come to the microphone. So Patrick, you make these points about this difference in KOW, which are some very serious physiochemical differences. And so if we accept that maybe that's too far, what would be acceptable? How similar do they have to be able to make that connection?
I think that has not been well characterized. So what I would need to see to be comfortable with using something that was that lipophilic in an in vitro assay and using that to make some kind of safety decision is some kind of assessment of the in vitro kinetics, how much of it is binding to the plastic, things like that. Is it, setting aside the IVIVE considerations, are we actually the AC50 that comes out of that ToxCast assay, is that even representative of what the concentration in the media is? And I think that we're well into the domain there with that degree of lipophilicity, where that it probably is not the case. It's something that with some more study we wouldn't have to necessarily test on a chemical by chemical basis, but to have some guidelines about what the relationship is between chemical properties and kind of the utility of the in vitro assays would be enough for me.
Gary?
So regarding the kinetics, I mean, focusing so much on the difference in lipophilicity, would you be concerned that, like for BPA, the glucuronidation happens so fast that the distribution, because lipophilicity is, you worry about distribution and how much is going to be stored, and et cetera, but, maybe there's other parts of the kinetics that are going to drive its fate, and so, how much do we need to know about the PK mechanism to really interpret that lipophilicity difference and its potential importance? And are there, just generic models for this class of compounds where you could, just sort of run something like that through and sort of test whether the standard uncertainty factors we already use might cover this case, or a database deficiency factor might cover the case and still make it usable. I mean, what to me was more concerning was that spread in AC50s. And like, what does that mean? If ToxCast is going to give you that much variability, and compared to the nonylphenol profile, which was much less variable across the ToxCast ER or endocrine-related outcomes. I mean, that to me looked fairly concerning.
So with the latter point, I think that may in fact be related to the high lipophilicity of the compound, that we're getting imprecise measurements of the AC50, the true AC50, if you will, for the dodecyl compound relative to the nonylphenol. With respect to the kinetics, there are competing factors here. So you might, with a very high KOW, you might be worried about bioaccumulation or other issues like that. On the other hand, what we see with other compounds that are somewhat structurally similar, where we have series of chain links, that the longer chain links tend to be metabolized more quickly and more thoroughly than the shorter chain link compounds. They have more opportunities for oxidative metabolism on the chain, and they're grabbed and metabolized more quickly. So I think there are some competing concerns there, which probably balance out to something that's not so extremely different, that we couldn't handle it with a typical sort of adjustment for that kind of uncertainty.
If you have a few minutes for Arnie Schwartz from GW. In that classical pharmacology that at any moment the drug can be along the spectrum of agonism and antagonism, do the two of you come up with certain critical points in terms of consensus whereby the nature of the similarity is not going from hypothesis creating, but hypothesis convincing? Are there, in a sense, criteria in this kind of drug analogy debate that are Hill-like, the Bradford Hill-like, where again you can be more convinced that the next experiment will follow you, so therefore you're at the level of hypothesis proving, as opposed to the next experiment can cause falsification, which would be hypothesis driven.
Lisa wants to take off her hat, but no, I would say that is very much in line with how I'm thinking of it. That this, when I talk about this kind of Bayesian philosophy, that maybe this, even if it's just incremental, maybe this lets you update your prior a tiny bit and says, okay, no, this is where we would have to go next. So I mean, John Vandenberg was saying yesterday that that's the weak use of any of these applications, that we could use them for hypothesis generation, and I think that's absolutely appropriate.
So Lisa, we'll let you take off your hat in the panel discussion, and we'll move on to topic 3. So thanks, participants.